Today we're going to clarify once and for all the difference between atomic number, atomic mass, and mass number. I mean, back in school, when I was taking some chemistry courses, I couldn't sleep just thinking that I had to know the difference between those terms that sound almost the same. But that will be over today, people. Time to put an end to any confusion. Before we define what those three terms are, we first need to establish a baseline understanding of the elements on the periodic table. All matter around us is composed of atoms, and all atoms are composed of three particles: protons, neutrons, and electrons. Protons have a positive charge, neutrons have no charge, and electrons have a negative charge. Atoms of the same element have a specific number of protons, neutrons, and electrons. Protons and neutrons form the nucleus, and electrons orbit around the nucleus in shells. With this background information about protons, neutrons, and electrons in mind, we can finally bring everything full circle. So let's start with a question. What's the atomic number? The atomic number, designated by capital Z, refers to the number of protons in the nucleus of each element. You can figure out the atomic number simply by looking at the periodic table. The periodic table is organized by atomic number. Hydrogen is number 1 on the periodic table, meaning it has 1 proton in its nucleus, and its atomic number is 1. Helium is number 2 on the periodic table, meaning it has 2 protons in its nucleus, so its atomic number is 2, and so on, all the way to the end of the table. When you learn the term atomic number, you will definitely learn 2 other terms: mass number and atomic mass. And this is the moment when you start hating chemistry, but you don't need to. The mass number of an atom essentially tells us how many protons and neutrons there are in an atom. So add the number of protons to the number of neutrons and you can get the mass number of an atom. Atomic mass, on the other hand, simply put, tells us how much an atom of an element weighs. Atomic mass is the average mass of atoms of an element calculated using the relative abundance of isotopes in a naturally occurring element. Although the atomic mass is technically the sum of the mass of all the protons, neutrons, and electrons in an atom, the mass of an electron is so much less than that of other particles that when we calculate the mass, we only consider the protons and neutrons in the nucleus. There seems to be a bit of an overlap between atomic mass and mass number, and there lies the confusion. Mass number and atomic mass are very similar because they essentially add units of neutrons and protons. However, remember that mass number is, like the name says, a number we get when we add the amounts of neutrons and protons in the nucleus of an atom, while the atomic mass happens to be measuring the weight of an atom, which considers only the weight of neutrons and protons in a nucleus. The trick to differentiate them is to remember that you will usually see atomic mass represented as a decimal number, followed by a unit of measurement called AMU, which means atomic mass unit. Since we brought them up a couple of times, I just wanted to give you a quick word on isotopes. Much like you have people in your family that are similar to you in some ways and different in others, elements have element families called isotopes. Isotopes are variations of elements that have the same number of protons but a different number of neutrons, which means that isotopes all have the same atomic number but a different mass number. Let's tie everything together using carbon as an example. Carbon has an atomic number of 6, meaning it has 6 protons in its nucleus. Usually on the periodic table, you find this additional number, which is usually a decimal number. And in the case of carbon, it is 12.011. This is the atomic mass of carbon. If we subtract the atomic number from the atomic mass, we will get the number of neutrons in an atom of carbon. Carbon also has 3 isotopes. Carbon-12, which has 6 neutrons. 6 neutrons plus 6 protons equals 12. Carbon-13, which has 7 neutrons. So we have 7 neutrons plus 6 protons equals 13. And carbon-14, which has 8 neutrons. 8 neutrons plus 6 protons equals 14. Note that these numbers 12, 13, and 14 are simply the sum of the protons and neutrons in these isotopes, so we call them mass numbers. I hope I was able to clarify these 3 terms for you, so now you can start sleeping again at night without having nightmares about them. There is more you can learn about what atoms are and what they're made of. So click on the video on the screen to start your journey through the beautiful world of atoms. Remember to like the video so you tell me and YouTube you want to see more of these, and subscribe to the channel so you don't miss the next upload. I'll see you next time.